presentation on OEM Insight into SDV by Mr. Nandeesh Rumalad, Senior Technical Specialist,
Okay.
Group Product Owner, Scaled Test Automation JLR, 2 decades of expertise in automotive validation and embedded systems. Can we all give him a huge round of applause, everyone? Mr. Nandeesh Rumalad. Along with him, we also have Mr. Kishore Karanala, Senior Technical Specialist, Jaguar Land Rover, with 20 plus years of expertise in SDV program. Can we all give him a huge round of applause as well?
Very good afternoon. Uh, I think uh, we had a very good sessions today morning talking about a lot of things on SDV, how hardware, software, and how the tools, different perspectives from the tooling, different perspective from the OEMs. So today I'm just trying to cover some of the insights of the software-defined vehicle. What is that it's going to be from the OEM perspective, and what is that it is going to be from the customer perspective. Yeah, myself, Nandeesh, 2 decades of experience in automotive, along with me, Kishore, who's going to talk about this session. As Charles Darwin said, that it's not the strongest of the species that survives, nor the most intelligent that survives. It's the one that is the most adaptable to change. That's the theory of evolution. And why it is so important today, because we as automotive industry is also going through that serious change in the way we think, in the way we adapt the technology, and how are we going to create our new future technology. It's important that we start evolving. It's important that we start be relevant for the technology and build the new age technologies in our automotive. So most of the things which are covered, that why SDV is needed, what is the necessity for SDV to be evolved. So as we understand, and most of the speakers today morning talked about, our hardware and software are very tightly coupled, and they are doing a very specific tasks. They are functioning for things. For example, if you look at the door zone module, which operates opening of the doors, closing of the doors, and then operation of the Windows system. After doing that, it's pretty much sitting in the car, but not doing anything, any other functions. But there is a compute, there is a software, and we are not able to evolve the vehicle. Though there is so much of compute, the vehicle doesn't get evolved much over the lifetime of the vehicle. And as most of us talked, almost 70 to 80% of the today's car are also running on the software. But though it is software, but we are not able to change, or we are not able to give new experiences, we are not able to give new features to the customers. That's where it becomes a necessity for us to build a software-defined vehicle platform. A software-defined vehicle platform which, as a OEM, we can provide features, functions over the entire vehicle ranges. So there will be different vehicle ranges, but we're not able to provide all the features, functions to all the car lines. And as a OEM, we want to give based on the personalities, what type of features, what type of functions, which can be enabled through our software-defined vehicle centers. Also, most of the features, though we don't want to sell a new vehicle line every 2 years, make a new car line, and then we want to sell the new car. Rather, we can upsell most of our features and functions because it is already there, the compute is there, it is connected, and then we can upsell a lot of those features directly to the customers. So many of people, we already tried to define what is an SDV. So it's not something which is new, I'm going to talk, but from our perspective, it's a technological evolution which is going to disrupt our traditional business models of the OEMs, and we need to do it with new innovation and deliver them at a speed to the customers. So that's what we define as an SDV, and what it actually brings to the table. So there are a lot of things which needs to be relooked from the vehicle perspective. One, the platform for connectivity. So we need to get a platform which is robust, safe, secure, as many of the people are questioning that how safe it will be, how secure it will be, and we need to make sure that we need to bring a strong platform for connectivity. So it's also going to generate a lot of data. When we have all the cars, all the vehicles, which are going to generate a lot of data, personalization information, and all of that is going to be put into the cloud. So it also becomes necessary that how much of data gets generated, how do we actually manage this data, how we can make that secure. Then, at the same time, we have to look at the different customer experiences. Now, coming to the Gen Z people, the new customers who are like very much passionate about gaming, very much passionate about new technologies, and they would require a different type of customers. So our customer base is going to be from male to female to different age groups. How can you actually curate different experiences to our customers? By doing this, it also opens up a channel that I can't only make money by making a car, selling that car and doing service, but we have to also look at the values, how I can make money, how I can sell those new features, how I can make my customer experiences better. So, in summary, SDV is not just about hardware consolidation. We need a unified end-to-end software architecture. We need a unified hardware architecture. We need a simplified electrical vehicle architecture. And we need a high bandwidth, high quality connectivity. And most important is the unified end-to-end process and delivery pipeline. A lot of today's sessions, we talked about the top four, having a connectivity, having the software abstracted, having our simplified architecture, zonal, central compute, etc. But the most important thing is our unified delivery pipeline. The unified delivery pipeline is about from the concept, making an architecture, and then going into the development, and then you connect it back to the test and validation, and then delivering to the manufacturing, and how the manufacturing can be simplified so that my feature lands into the customer hands. What will change? I think this is one of the important part which I wanted to cover is what would actually mean it for our customers? What can actually they expect? So first, as most of the panels also discussed about safe, yeah, we need to make our cars very safe. We need to look after our customers. Our customer needs to be feeling safe in the car, and then they can feel well. They can feel better that their car is taking care of them as well as their data, etc. And then connected. All of us in today's world are connected to our like-minded people, whether it's social media or it be office network communications or anything. So the connected is, we want to be connected, and this platform can give a lot of connected feature options to our customers. The third one, the productivity. A lot of our senior leaders sitting here in the room, and they have a lot of meetings. They have a lot of conferences, or they will be attending or sending out some emails. So this time, when they are commuting, imagine the commute time in Bangalore, this time can be used as more productive, and they can also do their bill payments, they can do their credit card bills, etc. So the car time, the commute time can also be used to be more productive. And then the entertainment. So not just looking at the people who are going to work and commute, but we'll also have a family and kids who are also sitting in the car. And they would need a lot of entertainment features to be added into our car. So the platform can enable to give a lot of OTT contents, whether they want to watch Netflix or Disney Hotstar. So this could be a platform to give a lot of entertainment features to the customers. And the explore, because now it is connected, it has all the information of the likes and dislikes of the customer, and the car can give you a better prediction. You want to explore the region, and it can provide you, create a travel itinerary based on your calendar, and then you can use that one. And we also want to spend time on learning. And all of us know how much of time we actually get to read the books today. So we're all dependent on a lot of audio books or other media which is available on the online content. So this can also be a platform where you can get your time to learn. And the last one, where you can also get connected and play some games, sitting in the rear seat, etc. So in terms of the customer experiences, so first we talk about seamless integration and with the mobile and the car. So now we get our phone, and most of our work happens through the phone, but when we actually get into the car, then we have to again dependent on our phone to do our work. So we can expect the seamless integration of our mobile phone to our car ecosystem, and then that can be extended to your home automation as well. And then the customer can expect the latest features, new functions, new updates on the different applications which are coming into the car, and we can expect a frequent updates on the car. And then the personalization. So though we all use the mobile phones, but then we also have different applications running on that. We have a different home screen, and we have different taste. And based on that, we will have our phone configured. Similarly, the personalization bit, wherein the car can detect your personality and your likes and dislikes, and you can configure various new features of the car. And now, because that it connects your, gets connected to your infrastructure, it can be used to give a step closer to the driverless. So don't mistake that SDV is going to be a driverless. It's only a enabler wherein when the ADAS gets level 3, level 4, level 5, and then that can be seamlessly integrated, and it can be a journey towards having a driverless cars. And the subscription options. So someone was talking about this, that I want to use seat heating during my winter, and I'm not going to use it for rest of the time. So there could be many more features like that, which could be applicable based on your geography, which could be applicable based on your needs, and then you can subscribe to only those features and then pay for that instead of paying for the whole car. And also the V2X communication, which would be a whole lot of applications which you can think with V2X. So in short, from the OEM perspective, what are the business objectives we want to achieve? One, the faster continuous innovation. That means we can give a better experiences to our customer. We can make better diagnostics, and since your car is connected and then you are collecting the data, and then we can also predict some of the issues which are going to happen to the car, and then we can be upfront, try to fix those bugs, and also give a real-time updates as much as possible. Of course, safety and everything comes into picture. And the second thing which we would like to have is reduce the number of hardware. So we have so many semiconductor challenges. We have been trying to fix those problems, and SDV is one of the opportunities wherein we can reduce as much of hardware dependencies, reduce the number of ICs in the car, reduce the number of computes, and also look at, as Radha was mentioning about what are the different networks which are available. So can we reduce those number of interferences and the different network options? And by doing so, you can actually reduce the total number of wiring harness. I think JLR, we have about 5.5 kilometer wiring harness length. Okay, so this could be an opportunity for us that in overall reduces the total carbon footprint, and we can also reduce the dependency on the copper and etc. And that can give you extra mileage which we want to drive. And Also, Radha mentioned about software and consolidation. So many variants of ECUs and so many variants of operating systems. By bringing it together and having one common simplified operating system by which we should be able to port our different features across different compute. So the most important, again, talking about the cloud first, right? So we all talked about connected. We can have our feature subscription, the data gets collected, and then do different analysis over the data. But our first principle is, can we actually not dependent on the onboard compute? Rather, how many of those features doesn't need to be on compute, and we actually try to develop them on the cloud? So we need to have a same architecture by which we should be able to use those applications as and when needed, and then we don't want, we can have only the safety critical operations to be run on the onboard compute. And next, the last one about enhanced connectivity by providing 3G, 4G, 6G Wi-Fi connectivity, which can be our interface to the external world. So these are the business objective. With this, Kishore is going to talk more about how we can actually implement some of the insights into technical details. Thank you.
So thank you, Nandeesh. So I will not take much time, but I will just try to, just talk about some of the stories that what is enabling SDV in JLR. So personally, I think most of us know this famous photograph taken by Voyager 1 sometime in 1990, after Voyager launched in 1977, approximately 13 years later. So the significance of this picture is, they have to take, this is not the intent of the Voyager 1, by the way, but the significance of the picture was they have to do a lot of calibration changes, maneuver changes, and pretty much they have to do the software over there, software over the space to make this happen. This tells a very important story. The hardware that was built 13 years back, we're able to change with the software, and still we are able to achieve what we want to achieve after 13 years. Interestingly, last year, I think, still the Voyager 1 was still running, and we have a problem with the Voyager 1. The maneuvers are not going very well. After 40 years, that is last year approximately, they have to do one more software update so that it can function by fixing some of the battery cells and some of the memory cells, which I will not get into the details. But the whole idea of this picture is, the whole idea of the story was predominantly about how a software can still make our hardwares live longer. That is whole perspective. I think this is one of the best inspiration that at least personally I get whenever I think about software-defined anything in this perspective, software-defined vehicle. Definitely, I'm not going to talk about this architecture because we already experienced, and we are all experienced with this architecture. But in OEM, I think what we are trying to do is that we are trying to build a framework in terms of how do we enable or how do we make sure our software takes more dominance in building our vehicles or hardware for obvious reasons or with respect to the experience. So one of the SOTA example, like in 2017, we deployed a SOTA on the first generation of the electrical vehicle architecture. It was not easy, obviously, because we have to change the entire end-to-end architecture, because that was not the purpose of that architecture that we built for in generation 1. Similarly, we want to integrate one of the perception model in generation 1 to save a lot of money, millions of, I think it's on millions. So we tried to force fit on that. We failed there because the hardware was not able to take it as much as we want. So there is a definite limitations on the hardware that we want to, use for the purpose on the legacy architecture. So whenever we have an opportunity, generally JLR or generally any OEM takes 4 to 5 years to spin up in any vehicle architecture. Whenever we are building any vehicle, we have a very narrow bandwidth of opportunity to inbuild a new vehicle architecture, but we have long waiting period. So we don't have so much of liberty going forward. So we build a framework based on some of the principles like modularity, scalability, and connectivity. These are some of the lessons learned based on our experience in the past, and based on the whatever the legacy systems that we have. So we have forced to use, or we started evolving into the consolidation of software, consolidation of hardware, where we have spoken about a lot. So what are our enablers? What is enabling us actually? Definitely one of the primary driving factor was that SOCs are becoming more and more powerful. So when I talk about the previous experience, I'm talking about the quad core with X number of DMIPs, which are very, very less with a 4 GB RAM, for example. That is a chip that we are talking about. Now I think we are talking about GBs. And then DMIPs are going almost like 10Ks above. So if I compute all my vehicle requirements on the compute, the latest SOCs, 3 SOCs are sufficient for me to run my entire vehicle. That is the capacity of the compute that are coming up. And advanced architectures, we spoke about containerization. So there are lot of technologies that are evolving, and definitely we will take those advantages in building up the architecture. Next one, the connectivity. So cloud first approach is something which we always talk about, where we don't want to develop the application just on the vehicle, but we also want to develop the application on the cloud so that vehicle can be served from the cloud. And the safety and security, quantum computer takes in seconds to hack our vehicle. Now we want really a strong encryption algorithms to protect our vehicles, because vehicles are going to be connected all the time. And then machine learning, I'm not going to talk about that, but only the point I'm talking about the sensor consolidation. So this is one of the important factors that we want. We want to pretty much use the sensor for multiple purpose, not just for a particular purpose which is defined for. And then the software factory, automation, I think we cannot underestimate that. This is something which, without saying that, it impacts the entire manufacturing line. And when we actually dig deeper, it is going to save a lot of money for us. You have time?
Thanks. Yeah. Thanks, Kishore. And most important, I spoke about how can we actually deliver value to the customer at a speed, right? If you look at this one picture, which has the DevOps cycle and the infinity loop in the center, and then it talks about starting from your day job, where you define your product requirements, where you define what is my application going to be, and how it actually cascades back into your continuous integration. And there are multiple processes. Someone talked about the headless automation, etc., in the past life, right? So all of this is going to be definitely mattering when we define our product backlog, and then how it can actually be defined in a way that we don't want to write the traditional way of writing requirements. How can we actually make it more software? How can we actually make it as more derivable directly using the latest Gen AI techniques? If I can actually generate the code, and if I can actually directly integrate that and have regular updates and builds happening through our CI/CD pipelines. And then most important is our virtual platform, the virtual test validation. So today a lot of challenge is because all our resources are thriving for the hardware. So we have developers, we have skilled engineers, but then if they have to validate, if they have to qualify some features and functions, they need an enabler which is called as hardware. They need test setups. So that's actually like each of that has a lead time, which eventually ends up in delaying our overall feature to customer, right? We would actually want to leverage latest technologies on the virtualization, where we can build the latest VSOCs by which we will be able to develop our code, we will be able to test our systems on the virtual cloud-based environment, and then reduce the dependencies on the hardware and the vehicle, and then give it to the customer. So yeah, that's all I wanted to touch on this. Yeah.
Just one final conclusion that I want to make is, we from JLR perspective, are we thinking like we are at there in the SDV? The answer is, I think we are half step there. We are not completely there. But what we felt while exploring our journey was, in the complete equation, the invention is completely missed out. So we are always piggybacking on the existing technologies and trying to retrofit into our SDV system and trying to make it work. But is that all? No, I think what we expect from each of our partners and each of our engineering colleagues is, definitely we need to think in terms of the inventions. For example, if I take an example of wireless technology, we are piggybacking on the existing wireless technology, which doesn't work on the automotive, but we need it. So just think about it, and thank you very much for your time.